In the final years of the Second World War, Germany was building aircraft that flew faster than anything the Allies had ever seen. Machines so advanced that some of their core technologies would not be matched by other nations for another decade. One of these aircraft could climb to bomber altitude in under 3 minutes, using a rocket engine so unstable that it occasionally dissolved its own pilots. Another was designed to be built by furniture factories using wood instead of scarce aluminum, flown by teenagers with barely 20 hours of training. This is the complete story of every jet and rocket aircraft Nazi Germany developed during World War II, a program defined by genuine engineering brilliance, catastrophic operational failures, and a desperate race against time that ultimately changed the future of aviation forever. But the strangest, most dangerous aircraft on this entire list is also the one fewest people have heard of, and we are saving it for the very end. Heinkel. E-178, before any other nation had successfully flown a jet-powered aircraft. Germany had already done it. On August 27, 1939, just days before the invasion of Poland, the Heinkel E-178 became the first aircraft in history to fly purely on turbojet power. Designed by engineer Hans von Ohain, who had developed his jet engine concept independently of British engineer Frank Whittle, the E-178 was a small experimental airframe never intended for combat. Its Has-3 engine produced barely 1,100 pounds of thrust, enough to prove the concept worked, but nowhere near enough for a practical fighter. The aircraft achieved a top speed of roughly 360 miles per hour during testing, respectable but not revolutionary on its own. What made it revolutionary was timing. Germany had a working jet aircraft flying nearly 2 years before any other nation in the world. The problem was that German high command, confident the war would be won quickly through conventional means, largely ignored the breakthrough. The E-178 was eventually destroyed in an Allied bombing raid on the Deutsches Museum in Berlin, and the years lost to bureaucratic indifference would prove costly when jet technology became desperately needed later in the war. Heinkel, E-280 building directly on the E-178's success. The E-280 became the world's first jet-powered fighter aircraft to fly, taking to the skies in 1941, a full 2 years before any operational jet fighter would see combat. Armed with 3 20mm cannons and powered by twin Hayes 8 turbojets, the E-280 demonstrated genuinely promising performance, reaching speeds over 510 miles per hour. It was also the first aircraft in history to be saved by an ejection seat. When test pilot Helmut Schenk's controls iced over in 1942 and he was forced to eject at altitude, the very first combat aircraft ejection in aviation history. Despite this innovation and its early lead, the E-280 program was cancelled in 1943. The Reich Air Ministry determined that Heinkel's competing engine supplier could not produce reliable jet engines fast enough, and resources were redirected toward a rival design from Messerschmitt that would go on to become far more famous. Messerschmitt Me 262. This is the aircraft most people associate with German jet technology, and for good reason. The Messerschmitt Me 262 Schwalbe was the first operational jet fighter to see combat anywhere in the world, and when it finally entered service in 1944, it was simply faster than anything the Allies could put in the sky. Powered by twin Junkers Jumo 004 turbojets, the Me 262 reached speeds of 540 miles per hour in level flight, over 100 miles per hour faster than the best Allied propeller fighters like the P-51 Mustang. Armed with 4 30mm Mk108 cannons, a single burst from an Me-262 could tear a heavy bomber apart in seconds. Allied bomber crews who survived encounters with the aircraft described it as appearing and disappearing almost too fast to track. But the Me-262's combat record tells a more complicated story than raw speed alone. Its Jumo 004 engines had an operational lifespan of barely 25 hours before requiring complete replacement. The result of Germany's wartime shortage of heat-resistant metals like chromium and nickel needed for turbine blades. Pilots reported engines literally melting during high-power climbs. The aircraft was also extraordinarily vulnerable during takeoff and landing, when its jet engines produced sluggish low-speed thrust response, leaving it dangerously slow exactly when Allied propeller fighters could catch it. Allied pilots learned to simply wait near German jet airfields and ambush the Me-262s as they were landing, low on fuel and unable to accelerate away. Adolf Hitler further complicated the program by initially insisting the aircraft be converted into a fast bomber rather than a fighter, delaying its combat debut by nearly a year during a period when Germany desperately needed fighter defense against Allied bombing campaigns. By the time the Me-262 entered widespread service, fuel shortages, pilot training shortfalls, and the sheer scale of Allied numerical superiority meant the aircraft, brilliant as it was, could not change the outcome of the war. Messerschmitt Me 262 variants, several specialized versions emerged from the base Me-262 design. The Me-262A1A was the primary fighter variant, while the A2, a Sturmvogel, was the bomber configuration Hitler had originally demanded. The B-1A was a two-seat night fighter variant, equipped with primitive FUG 218 Neptune radar, hunting Allied bombers in darkness when conventional fighters were blind. Each variant shared the same fundamental engine reliability problems, meaning no matter how the airframe was configured, the same 25-hour engine lifespan haunted every single one of them. Messerschmitt Me 163 Komet, the Me 262 was Germany's triumph. The Me 163 Komet was its nightmare. This was not a jet aircraft at all, but a rocket-powered interceptor, and its performance was almost unbelievable for 1944. The Komet could climb from ground level to 30,000 feet in under 3 minutes, reaching speeds approaching 590 miles per hour, faster than any propeller aircraft of the era, and competitive even with the Me-262. Its tailless, swept-wing design was decades ahead of conventional aerodynamic thinking. The problem was its fuel. The Komet's Walter HWK 109-509 rocket engine ran on a combination of T-Stoff, a concentrated hydrogen peroxide solution, and C-Stoff, a hydrazine hydrate mixture. These chemicals were so violently reactive with each other that any leak or improper mixing caused spontaneous explosions powerful enough to vaporize the aircraft and pilot instantly. Ground crews wore protective acid suits simply to fuel the aircraft, and there are documented cases of the corrosive T-Stoff dissolving pilots who survived crash landings, their bodies essentially chemically destroyed before rescue crews could reach them. The Komet's rocket fuel provided only about 8 minutes of powered flight before it had to glide back to base, meaning pilots got a single brief opportunity to engage enemy bombers before becoming a powerless glider in hostile airspace. Landing was equally dangerous. The aircraft used a jettisonable takeoff dolly and a retractable landing skid, and any leftover fuel in the tanks during a hard landing could detonate on impact. More Komets were lost to accidents, fuel explosions, and structural failures during high-speed flight than were ever lost to enemy action. It remains one of the most genuinely dangerous aircraft ever placed into operational service by any air force in history. Heinkel He-162 Volksjäger B. Late 1944. Germany's war situation had become catastrophic, and the He-162 Volksjäger, literally people's fighter, reflects exactly how desperate the Reich Air Ministry had become. Designed and rushed into production in an almost unbelievable 90 days. The He-162 was built largely from wood rather than aluminum, because Germany's aluminum supplies had been devastated by Allied bombing of industrial centers. The aircraft was intended to be flown not by experienced Luftwaffe veterans, but by Hitler Youth glider pilots with minimal flight training, a plan born from Germany's collapsing pilot training pipeline after years of attrition had killed most of its experienced aviators. The single WWII turbojet was mounted above the fuselage in a configuration that created serious handling problems, and the wooden construction proved structurally unreliable at the aircraft's top speed of 562 miles per hour, with several prototypes suffering catastrophic glue joint failures in flight. The war ended before the planned mass deployment of teenage pilots in wooden jets could be fully realized, sparing Germany from what would likely have been a slaughter of inexperienced young aviators against veteran Allied pilots. Ba 349. Natter. Perhaps no aircraft on this list better demonstrates wartime desperation than the Ba 349 Natter, a vertical launch, semi-disposable rocket interceptor designed for a single mission profile so extreme it bordered on a manned missile. Launched vertically from a rail using 4 solid-fuel booster rockets in addition to its own Walter rocket motor, the Natter would climb almost straight up toward Allied bomber formations, fire a single salvo of unguided rockets from its nose, and then the entire aircraft would essentially come apart by design. The forward fuselage containing the engine was discarded. The pilot and rear fuselage descended together by parachute, and theoretically, the aircraft could be assembled again for another flight using new components. The single-man test flight, conducted on March 1, 1945, ended in catastrophe when pilot Lothar Sieber was killed during the violent vertical launch, likely due to the canopy detaching and striking him, or a structural failure during the extreme acceleration phase. The program was abandoned shortly after, having killed its only manned test pilot before ever completing a successful test of its core mission profile. JUNKER Ru 287, while most German jet development focused on interceptors defending against Allied bombers. The Ru 287 represented a radically different approach to bomber design. Its most distinctive feature was forward-swept wings, the opposite configuration of nearly every other swept-wing aircraft developed during this era. Engineers believed forward sweep would provide better low-speed handling and stall characteristics for a heavy bomber, critical advantages when carrying a full bomb load. The prototype used a cobbled-together fuselage from a captured Heinkel He 177, mounted on a temporary fixed landing gear arrangement, and powered by 4 Junkers Jumo 004 engines, the same engines used in the Me 262. Test flights revealed the forward-swept wing design suffered from severe aeroelastic divergence, a phenomenon where the wings would twist and flex dangerously under aerodynamic load at higher speeds, a problem that would not be properly solved in aviation engineering for several more decades. The war ended before a production variant could be finalized. Arado AR-234 Blitz. The AR-234 Blitz holds the distinction of being the world's first operational jet-powered bomber, entering limited service in 1944 and conducting the very last Luftwaffe bombing raid of the war against Allied forces during the Battle of the Bulge in early 1945, powered by twin Junkers Jumo 004 engines identical to those used in the Me 262. The Blitz could outrun virtually every Allied fighter sent to intercept it, making it remarkably effective for reconnaissance missions deep over Allied territory. Its takeoff procedure, however, was bizarre and dangerous, with early variants relying on a jettisonable trolley for takeoff and a retractable skid for landing, since there was no room in the slim fuselage for conventional landing gear. This system proved unreliable in field conditions, and later production models incorporated conventional retractable landing gear instead. Despite its impressive speed, fewer than 215 AR-234s were ever produced, far too few to influence the war's outcome. Horten Ho 229. This is the aircraft we promised you at the beginning of this video, and it remains one of the most genuinely mysterious designs to emerge from any wartime aviation program. The Horten Ho 229 was a flying wing, a design with no separate fuselage or tail section at all, built by brothers Walter and Reimar Horten, who believed this configuration offered superior aerodynamic efficiency and reduced drag compared to conventional aircraft. Powered by twin Junkers Jumo 004 engines buried within the wing structure itself, the Ho 229 achieved a calculated top speed exceeding 590 miles per hour, faster than the Me 262. while its flying wing shape gave it a significantly reduced radar cross-section compared to conventional aircraft of the era. Decades before stealth technology became a recognized field of aviation engineering. Modern analysis conducted by Northrop Grumman, the company behind the B-2 stealth bomber, found that the Ho-229's wooden and carbon-infused glue construction may have genuinely reduced its detectability to contemporary radar systems. Though whether this was an intentional design goal or a fortunate side effect of using available materials remains debated among historians. Only one prototype, the Ho-229 V3, was completed by the time American forces captured the Gotha factory producing the aircraft in April 1945. That single airframe was shipped to the United States for study and remains preserved today at the Smithsonian's Stephen F. Udvar-Hazy Center, a strange, silent reminder of a war that ended just before its most advanced aircraft could ever take flight in combat. Taken together, these aircraft represent one of the most concentrated bursts of aviation innovation in human history, compressed into roughly 5 desperate years by a regime that understood it was losing a technological race it could not afford to lose. Genuine breakthroughs emerged from this program: swept wings, ejection seats, jet propulsion at operational scale, and flying wing aerodynamics all trace meaningful lineage back to these aircraft. But innovation alone could not overcome Germany's collapsing industrial base, its catastrophic fuel shortages, and a pilot training pipeline that had been bled dry by years of attrition warfare. When American and Soviet forces overran German aviation facilities in 1945, they did not just capture aircraft, they captured documents, engineers, and design philosophies that would directly shape the first generation of Cold War jet fighters on both sides of the Iron Curtain. The Me-262 swept-wing data influenced both the American F-86 Sabre and the Soviet MiG-15. The Horten brothers' flying wing research would echo decades later in stealth bomber programs developed an ocean away. Germany lost the war in 1945, but in the strange architecture of jet engines, rocket fuel, and swept wings these engineers left behind, they had already won the opening chapter of a technological race that would define the rest of the 20th century.